Hello. Lesson 4 is going to talk about functions and function notation. So we have some definitions to start. A relation is going to pair two different things. So generally it's our inputs and our outputs, which are our x and our y's. Okay, when we have any sort of relation, we always have domain and range. So domain always deals with our input, which is also the independent variable and also known as the x value. Our range then is the output values. So we have y values, and we also refer to those as dependent variables. We can further describe what a function is. So a function is a specific type of relation where every element in your domain or your x value is mapped to one and only one element in the range. So here's an example. We have an xy table, so input, output, and we have every single x value being paired to one y value. Okay, here's another example. So we have, let's look at the table on the left, or the diagram on the left. We're wondering, is it a function? Well, we said that every input is paired to exactly one output. So -5 only has one output, and 6 only has one output. Therefore, this is a function. Okay. The domain would be -5, and 6 in your range talks about your output, so that is 3. This xy table over here on the right, though, we have to decide if this is a function. So we ask ourselves, is every x value or every input mapped to only one y value? And we see an issue here because we have -2 mapped to 0 and -2 mapped to 3 as well. Therefore, this table is not a function. Moral of the story is, in order to be a function, your x value or your input cannot repeat. Okay. An easy way to tell whether a graph is a function is to use this test called the vertical line test. So here's how it works. Since our x's cannot repeat, we're going to draw a vertical line over our graph. And if our vertical line touches 2 times or more, it's not a function. And if the vertical line touches once, then it is indeed a function. So here's an example. Just a random curve drawn on our graph. We draw in vertical lines. We notice that each vertical line only touches my graph one time. Therefore, this x value is only mapped to one y value, and this x value is only mapped to one y value. So we have a function with this graph. Looking at this circle, we see our vertical line touches 2 times. Therefore, this is not a function. I want you guys to answer, is this graph representing a function? Okay, last thing we need to talk about today is function notation. So function notation looks like this, and we pronounce that f of x. So the reason for function notation, it helps tell different functions apart. So if I gave you these two functions and I said plug x equals 2 into your equation, you wouldn't know which equation to go to. So we rename them g of x, h of x. This could be almost any letter. So we use function notation to separate the two. Now I could say find g of 2, and you would know you're strictly looking at this function. So here is g of 2. That means that wherever this x was located, now I'm going to plug in a 2. So instead of 2x, I have 2 times 2 minus 7. And then we just simplify that down to -3. Okay, then we could find h of -5. Now make sure you realize that, yes, I'm given g and h, but this only asks for h of -5, so I can disregard g. And I'm really only going to plug that -5 into that h equation. And that leaves us with -23. Okay, here are two functions. H of x is 4x minus 3. P of x is x squared minus 3x. I would like you guys to find P of -3.